You're welcome to my YouTube channel once again. Today we have to prove the following infinite series problem, that this sum is equal to pi squared all over 6. Now these are the diagonal functions in this case here. So we have that the diagonal of k is equal to the minus a Masonic constant plus integral from 0 to 1 minus x raised by k minus 1 over 1 minus x dx. Okay, now this diagonal n plus 2 all over 2 can be represented. That is diagonal of n plus 2 over 2 will be minus 0 Masonic constant plus integral from 0 to 1 minus x raised by n all over 2 over 1 minus x dx, and the diagonal of n plus 1 over 2 is equal to minus a Masonic constant plus integral from 0 to 1 minus x raised by n over 2 minus 1 all over 2 over 1 minus x dx. Okay, now with a proper simplification here, so when we subtract them, n plus 2 over 2 minus the diagonal of n plus 1 over 2, this is going to give us 2 times integral from 0 to 1 of x raised by n over 1 plus x dx. So denoting this sum problem using I, so we have I is equal to sum as n goes from 0 to positive infinity minus 1 raised by n open bracket 2 integral from 0 to 1 x raised by n over 1 plus x dx squared. Okay, and when this is squared, remember this 2 will be taken out, so we have this to be equal to 4 sum as n goes from 0 to positive infinity minus 1 raised by n integral from 0 to 1 integral from 0 to 1 all over 1 plus x 1 plus y, okay, xy raised by n dx dy. Okay, now we have to evaluate this series in this case here. So we have sum n goes from 0 to positive infinity of xy raised by n minus 1 raised by n, and this is the same as 1 over 1 plus xy. So we have that I is equal to 4 integral from 0 to 1 integral from 0 to 1, okay, 1 all over 1 plus x 1 plus y 1 plus xy dx dy. Taking the substitutions, that is taking xy equal to k. Now when we take xy equal to k, so we have the following: 4 times integral from 0 to 1 integral from 0 to y. Okay, when we take this substitution here, we differentiate with respect to s, so meaning we are taking the integration with respect to s in this case. So we have 1 all over x plus y, x plus, that is k plus y, I mean 1 plus y 1 plus k, so the k dy. Okay, now according to Heaviside cover up rule, so that is discomposition into partial fraction. So we have I is equal to 4 integral from 0 to 1. We have here 1 all over 1 all over 1 plus y times integral from 0 to y 1 all over 1 minus y open bracket 1 over y plus k, okay, minus 1 all over 1 plus k close bracket dk dy. Okay, and here when we integrate this place, this is natural logarithm of y plus k, and when we put the limits and integrate this side, once we take the limit, so our I is going to look like this: I equal to 4 integral from 0 to 1 of the natural logarithm of 2 all over 1 plus y over 1 minus y squared dy. And if we take the substitution here, that is saying let y equal to 1 minus y over 1 plus y here. So this will be transformed to, it is 2 times integral from 0 to 1 natural logarithm of 1 plus y over y dy. Okay, now we need to know the power series expansion of natural logarithm of 1 plus k in this case, and this is the same as as n goes from 0 to positive infinity, minus 1 raised by n, k raised by n plus 1 over n plus 1, where minus 1 is less than k and k is less than or equal to what? 1. Okay, now we have I to be equal to 2 sum as n goes from 0 to positive infinity, minus 1 raised by n all over n plus 1, integral from 0 to 1 of y raised by n dy, and this is the same as 2 sum as n goes from 0 to positive infinity, minus 1 raised by n over, when we integrate here, so this will become n plus 1 squared. This is the same as, okay, negative 2 sum as n goes from 1 to positive infinity, minus 1 raised by n over n squared. Okay, now according to the dilogarithmic function here, so we have this I equal to minus 2 LI2 of minus 1, and this is equal to minus 2 times LI2 of minus 1 is minus pi square all over 12. So, and this is equal to pi square all over 6. Thank you for viewing, and make sure you subscribe to my YouTube channel for more interesting videos.